All right. Our last 3 weeks. So the schedule is we're going to finish chapter 5 this week. Today's homework is problems out of 5.2. Thursday will be 5.3, then we're done with new material. So next week, actually I thought about giving you guys the choice, although it pretty much will have to be unanimous to change it. The current schedule is, week from today would be review for the 4th exam. And we take the 4th exam a week from Thursday. And then the last week, both Tuesday and Thursday, we take the final exam. Final exam is 2 parts. I guess the only option would be if you wanted to have a review for the final exam, then take the 4th test next Tuesday and not have an actual class for review. Or
could we review some on Thursday?
Or review some on Thursday and take the test on Tuesday.
So that way we would have a full review day for the final exams.
While you're thinking about that, I'm going to go ahead and pass out. This is the review. Wow. This is the review for the 4th test, right? You always have a review. There are sort of 2 parts to this. This section from chapter 4, and then the integration stuff. I guess theoretically, maybe what we can do is maybe I'll create an announcement, and then next class you guys can decide. Or here's what I'll do, it's even better. I will put out an announcement, and you can respond back to me with your choice. And then for those who don't read their announcements, obviously they don't get a vote. That'll be a reward for people who read their announcements, and now you learn. So you might have a problem with that. So I'll explain in the announcement. Basically the option is, do you want to take a whole class to review for the 4th test, or do you want to have a class to review for the final exam? We can go ahead if you choose to take the 4th exam a week from today, then we will go over the homework on Thursday, and then, you know, we probably will not have a quiz and just take the rest of the class then to review. And I think there's actually not a huge amount of material for this last test. I mean, if you look at the review, right, there are taking the derivative of exponential functions, right? You just got to remember the rule. It's pretty straightforward. It's not a hard thing to do. And then taking the derivative of natural log functions, which once again is a pretty straightforward 2-step process. Of course, in the middle, a couple little story problems where you can apply that stuff. And then part 2 of this is what we're doing now, where we're learning to take integrals. This stuff here, what's called definite integrals, where you have the little numbers at the top and the bottom, that's what we're going to cover in 5.3, which is not really that hard. So, I will send out an announcement. I will give you guys a chance to respond back with your choice, and we can either do it the American way and let you guys decide, or we'll do it the English way and I'll be the king and I'll decide. You Americans like your democracy stuff, so and you guys can decide. Either way, from my standpoint, I am like a king in here, but I'm benevolent, right? A nice king. I'm not too mean to you guys, hopefully.
Is it recording?
It is recording because a couple of people are sick and they want to see the homework. Does it say record? Oh, you can see the clock.
Yeah.
I hope it works because they were asking to see the homework later today, so. Yeah, so if you don't, if you like say something about me that's bad, it's going to be recorded, so you have to really be on guard today. What you say. You ask your questions. All right, so in a minute, let me take attendance so I don't forget. Let's just do this. Yaslin, Jacob, Daniela, Emma, Ashby, Justin, Lucas, Gina, Noah, Mackenzie, Eli, Hayden, Wesley. We are going to have our normal quiz in the class. Now this is the one, remember last week I was already sort of trying to sneak in some final exam review. So this was the quiz from last class. So I'm going to work through this real quick. And then in a class you'll get this quiz back. And of course you can make corrections and turn it in again. So this was, I told you these are some questions that are going to be on the first part of the final exam, which you may have forgotten because we haven't really done these kinds of problems. Once we started doing derivatives, we didn't really do this stuff much anymore. So these first problems were limits. You notice the first three are limits as x approaches a number, and then 4, 5, and 6 are as x approaches either positive or negative infinity. Some of you did okay. Some of you had probably already forgotten how to do these, but you need to be able to do these before the final exam. So if you remember, the way we do limits as a number, you go and stick in whatever x is approaching, plug it in for x and see what happens. So as x approaches 4, 4 plus 5 over 4 minus 1, 9 over 3, which is 3. If this thing equals a number, then you're done. The answer is just 3. Remember, there's going to be 3 possibilities when we solve these kinds of problems. This is the one possibility. This next one, plug in 3 for x. It's going to be 9. 3 times 7 is 21 plus 12 over 3 squared is 9. If you do the top here, All right, this is that sort of unique situation where sometimes you get 0, 0. What we do when that happens is we go back to the original function and we see if we can maybe factor and if some things cancel out. And if it does, then we go ahead and look at the limit again. So as it turns out, in the top it's a trinomial, which is actually can be factored into x minus 4 times x minus 3. And the bottom is a difference of squares. Once we factor it, we notice in the top and the bottom, we have a common factor, x minus 3 parenthesis. So once we do that, we're going to try and take the limit again, except now the function has been reduced to x minus 4 over x plus 3. Now I plug in 3 for x. It's going to be negative 1/6. All right, any questions on that? Hopefully you're like, oh yeah, I remember that. The last one where x approaches number, x approaches negative 1. So once again, it's like negative 2 minus 7 over 4 times negative 1, negative 4 plus 4. So it turns out these are the three things that can happen. First one equals a number, second one 0, 0, last one is a number over 0. Of course, anytime you try and divide a number by 0, that's undefined. So in this case, there is no limit. Any questions on those? Now the next three are the ones where we're looking at limits as x approaches infinity, either positive or negative. We do these problems totally different. The way I like to do it is I get rid of everything but the leading terms, right? Leading terms means the terms with variable with the largest exponent. So here, I'm going to ignore the 5. I'm going to ignore this minus 1, ignore the 6x, ignore the minus 5x squared. So basically it becomes this problem, 4x cubed over 2x cubed. Now since the x cubes cancel, four over 2 is 2. Well, turns out the variables are gone, so the limit is just 2. Remember, that's what happens when your leading terms, when the leading terms have the same exponent, the same variable with exponent. It's just the ratio of these coefficients. Here, a lot of times you can do these in your head, but I'll work it out just in case some of you forget actually what's going on. Once again, leading terms now when you cancel. So once again, you say to yourself, all right, so what if I plug in a huge, in this case, if I plug in a huge negative number in for x squared, so like 1 over negative a million squared, what does that equal? Negative 0.00000000, or basically it approaches 0. So that's what happens when the top exponent's less than the bottom exponent. Just coming back, hopefully, everybody. Once again, it's interesting also, I said up here, when you have limits going to numbers, 3 things can happen. For these kinds of limits, there's also 3 possibilities. The exponents in the top and the bottom are the same. Exponent in the top is less than the bottom. Here, By the time we reduce to leading terms, x over x, so in this case the exponent on top is greater than the bottom, which to me it's always sort of interesting in math. I accept it if you say the limit is infinity, although sometimes in the world of math, infinity is not really a number, so can that be a limit? So sometimes people like to say there's really no limit because it's just going to keep increasing. I'll accept either answer. So any question on those limit problems? You'll see those on 2 weeks from today. You'll see it when I hand out the first part of the final exam. Now, I sort of messed up on this next part. I also said there's going to be some of these continuity questions on the final exam, so I gave you a couple of those. This is the piecewise one. And the instructions are, for the functions below, list all the values for which the given function is not continuous. If you recall, when you have a piecewise function, the only possibility for it not being continuous is at the transition point, when the function changes. So with these problems, these piecewise function problems, you simply plug in x equals 1 to both functions and see what happens. When I plug in 1 here, it's 3 minus 5, so it's minus 2. I guess I can write it out. And here, 1 squared minus 3, which is minus 2. So if those are equal, that means the piecewise function, when they come together, they actually meet at the same point. So the function's continuous. There's not a break or a gap. So you would say there are no points where it's not continuous, or give the old sign like this. Now here's where I messed up. This next one, this actual problem, let me tell you, all right, let me work it out, then I'll tell you how I messed up. Same kind of thing, piecewise function. Here the transitions is 0. The only place it might not be continuous is when x is 0. So you plug in x equals 0 and you get minus 3. You plug in x equals 0, you get minus 3. So once again, the answer is there are no points where it's not continuous. Well, that's not very interesting because that's just like the problem you had before, and that's where I messed up. What I should have done is made this like let's do this because this is the kind of problem you might have in the final exam. So what if I had not messed up and made it the problem like this to make that second function x squared minus 4? Then when you plug in 0, you get minus 3 and you get minus 4. Then you say it's not continuous when x equals 0. In other words, in this case, the transition point, the two functions come in and they don't equal. There's like a gap there. This is the problem I meant to give you, but I messed up, so. And the last ones are when you're given a function like this, all you have to look at, the only places where it might not be continuous is whenever the denominator of the fraction, whatever values of x causes the denominator to be 0. Because if you recall, those are going to be like vertical asymptotes, right? If you look at a graph of the vertical asymptotes, that's where you have those. You have those breaks or gaps. Well, that comes from the denominator being 0. So x squared minus 9, if you factor it, that function is not going to be continuous at x equals plus or minus 3. Some of you just put 3 down, but that's already correct. It's got to be plus or minus 3. This one's a little tricky. So I'm looking for the values of x that would cause the denominator to be 0. Once again, one of my standing offers. If you can give me a value of x that causes the denominator to be 0, I'll do something very special for you. I want to give you money. It'd be something better than that. Bottom line is, the denominator can never equal 0. For that to happen, I would need x squared to be minus 9, which is impossible. You can't square something and get a negative number. So this is a case where everything's continuous. All right, this is the final exam, part 1 review. So you've got that quiz back, or at the end of class, if you're not here last class, I can give you a quiz for you to, if you need to fix that, you can turn it in and get some more points. All right, so let's go ahead and get started with homework. Today is substitution. Remember I said last class that when you're taking derivatives, you can take derivatives of just about anything. But when you start taking integrals, it's not the same way. Integrals are much more selective and picky. You can't always take the integrals of certain functions. And because of that, sometimes we learn little tricks, little things to do so that we can go ahead and figure out integrals. And one of the little tricks, or the things we learn to try, is this thing called, in the world of math, there's lots of times when you're trying to solve problems where we have to do what's called substitution. Substitution is where, if you're given the problem with the variable x in it, substitution means somehow you replace all the x's with u's, and if you do it in a certain way, when the variables become u, then you can actually finish the problem. So in our case, we're trying to take an integral, and when the variable's x, we're sort of stuck. We don't have any rules that works for that integral. However, if we're smart and do it in a clever way and switch everything to u, then all of a sudden we are able to solve the integral. Of course, in the last step, so after you solve the integral, your variable is going to be u, but you have to switch u back to x to sort of finish the problem. So it's like wanting to fly to LA, right? You have a choice. I mean, do you have to fly through Denver or Dallas? That's what we're doing here. So let me grab the homework, and as usual, if there are any of these you want to see worked out, we can start with those. Looks like there were 13 problems assigned, so you can, before you turn your homework, you can mark down how many you attempted out of 13. And I will go ahead and write down which problems you would like to see. So who wants to see which problem?
23.
11. 39.
37.
37. Anything besides 11 before 23? All right, let's jump in with 11. So these problems, this is sometimes there are things you do in math that, and the way in the video, hopefully y'all watched it, there are definitely steps to follow. The tricky thing can be tricky sometimes, and the more you do these kinds of problems, the better you get. But the really key decision you make up front is you have to figure out what you want to set u equal to. And I think in the video lectures, according to the kind of problem you have, that usually helps you decide what u should be. Although sometimes it's not always totally obvious, and sometimes you just have to choose what you want u to be, and you start the problem, and if it looks like it works, then great, and if it gets worse, it gets messier, then you go back and say, well, let me try something else for you. But most of these, hopefully you can go ahead and figure out what u is, and if you make a good choice, then you're good to go. So 11 is integral of t times, in parentheses, t squared plus 1 raised to the 5th power. Now, one of the rules of thumbs is, it usually works pretty well, if you ever have parentheses raised to an exponent, a pretty good guess is whatever is inside the exponent usually ends up being what you should call u. So then here's the steps I went through on the video lecture. Here's the way I do it, which, once again, I tried to come up with a way that, to me, makes sense, and it's like you can follow the steps every time the same. So once you decide what u is, now don't get confused, right? Because now I'm actually taking an integral. So I'm taking a derivative. I'm going back to what we were doing 2 weeks ago. I'm taking derivative of this with respect to t. So I've got to remember your derivative rules. So I've got du dt equals 2t, but what I'm going to do is I'm going to take this little equation, I want to solve it for dt, meaning I want to get dt by itself. The reason why is, here's what I started with, and I want to convert all the t's to u's, including this dt. So this right here, when I solve for dt, it's going to give me a way to get rid of this dt in my original problem. So you do a little bit of algebra, and I usually write it like this. Basically, you divide both sides by 2t, you multiply both sides by dt, and you get dt equals 1 over 2t times du. So once I define my u, once I figure out what dt is equal to, now I can go back here, and hopefully, if I substitute and get rid of all the t's, then if this is working correctly, I'll have an integral with u's that I can actually take the integral of. Now sometimes it's a little tricky because I got this initial t here, I'm sort of stuck. I can't replace it with anything for now. I just have to leave it and hope that something works out. Now the parenthesis t squared plus 1 is u, so this raised to the 5th power becomes u raised to the 5th power. Now my dt is 1 over 2t times du. Now what happens here is, I had to go and write this t down. Didn't really want to, but I had no choice. But as it turns out, when I substitute for dt, there's a t down here. And this is great because those t's cancel out. And then actually I've accomplished my goal. I'm going to bring this 2 out front. So basically now I have an integral of u to the 5th du. Well, I know how to solve that integral. That's just the power rule for integration. U to the 6, add 1 to the exponent, divide by the new exponent. So now, once again, when I started out, I wasn't really able, I didn't have any rules. I was not able to integrate this function. When I did substitution and switched everything to u's and was sort of clever about what I chose u to be, turns out I was now able to integrate it with respect to u. So here's my solution with the variable u. Of course, my solution needs to have t's in it. So the last step is I need to switch now from u's to t's, and all you do is you go back to your original definition. So 2 times 6, this is like 1/12, u to the 6. All right, any questions on that? Now I'm surprised, sort of, that no one asked about 29. Actually, when I did that the first time, first time I tried it, it didn't work, and I had to go back and try something else. 29 is pretty messy, but I guess someone did ask about 23. So 23 was natural log of 5x over x dx. And once again, if you do a few of these, you get to the point where you sort of look at it, and I need to try substitution because I cannot integrate this. And you get to the point where someone might initially say, well, maybe u should be 5x. What's inside the natural log? You can try that, but you'd get sort of stuck. So it turns out when you have a natural log, what usually works is you make the whole natural log to be your variable u. So you follow the same steps. Once you define what u is, you take the derivative of u with respect to your other variable. Derivative of natural log of 5x. Now you got to remember our rules for taking derivative of natural logs, right? You put 1 over whatever's inside the natural log, then you multiply by the derivative of what's inside the natural log. Derivative of 5x is just 5. So it turns out the u dx is actually 1 over x. Now what I'm going to eventually have to do is to get rid of this dx up here, so I'm going to solve for this dx here. So in this case, dx is going to be x times du. So now let's do our substitution, and hopefully I can switch all these x's to u's, and it would be an integral that I can actually work out. So natural log of 5x is just u. Now right now that x, I'm sort of stuck with it. I can't really get rid of it for now, so let's just let it tag along and hopefully things will work out. Then dx is x times du. And once again, since it's almost December, since you guys have been good all year long, you get rewards this time of the year. So our reward is the x's cancel out. And we're able to integrate this. Pretty straightforward power rule. So I now have integrated it with the variable u, but now I have to switch back to the variable x. So u squared will be natural log of 5x squared. All right, I forgot who asked about this. Whoever asked about it, you okay? Understand what we did here?
Yeah.
Um, 37. Instructional 37, solve the given initial value problem. So this is one where you're still going to take the integral, but instead of, like the previous problems, instead of just having an integration constant, they're going to give you a point on the function where you can actually solve for C. That's why I wrote the difference between 37 and what we've done so far. So 37, so what they really want is we want to solve for y as a function of x, so y equals something with some x's in it. And they tell us, here's how they word it. They say where y equals 0, another way of saying that is they really have given you a point on the function 0, 0. So when we get all done, we'll have our integration constant, but we can plug in 0, 0 for x and y, and we can solve for the integration constant. But the first step is we need to take the integral of 3 minus 2x quantity squared. Now this is one you could, I'm going to go ahead and do substitution just because it'd be good to practice it. Does anybody have an idea of another way to solve this integral other than substitution? Actually, it wouldn't be too painful.
You could just times it out.
You could like FOIL it, right? I mean, if you FOILed it, by FOILing it, you know, this would be be 9 minus 10x plus 4x squared. You could take the integral of that. But don't count on it, because what happens if this had been the problem to the 5th? Then you don't want to multiply it 5 times. So you need to know how to do substitution. But for this one, you could have done it that way, like on a test, if you just wanted to do it that way. It's like, well. But let's do substitution just to be safe, in case in the future we need to use it. So once again, we got parentheses raised to an exponent, so it's always pretty safe to assume the parentheses are u. And then once again, same steps, you go ahead and take the derivative of u with respect to x. It's minus 2. I take this little equation, I want to solve it for dx. In order to get dx by itself. So now I'm ready to do my substitution and see what happens. 3 minus 2x is u, so this is like u squared. Dx is negative 1/2 du. I'll just move the 1/2 out front. And then we know how to integrate this function. So it's negative 1/2 u cubed over 3 plus c. Switch back to x's, so 2 times 3, it's like negative 1/6. U is 3 minus 2x. Now in the previous problems we were done, but because they gave us this point, the purpose of them giving you this point is to actually determine a number for this integration constant. So I'm going to plug in 0 for y, 0 for x. That allows us to solve for c. So 0 equals negative 1/6 3 minus 2 times 0 cubed plus c. So now two times 0 is 0, so 3 minus 0 is 3. 3 cubed is 27. It's pretty ugly. It's like a fraction. I believe move it to the other side. Looks like c is 27 over 6. You get answers like that, you say to yourself, wow, that's a pretty, I thought it would have been like 3 or 7 or minus 5. But I'll check in a minute. I hope I didn't mess up. So this was 37. Oh, I did sort of mess up. You should always reduce fractions, right? Actually, 3 is a common factor. I did the same thing in my homework. I left this 27 over 6, but I should have made it 9 over 2. Any questions about this? Sort of, the integral is actually pretty easy. You just had to know how to find the integration constant. And then 39. So basically, they want us to find y, and y is going to be the integral of 1 over x plus 1. This one, we may or may not have had one before, but actually, at some point, when you try and figure out, well, we don't know how to integrate this. We don't have any rules for this, so we're going to use substitution. I'm not sure we've had one like this before, but if you were just saying, well, what could or should u be? Hopefully it's about the only thing it could be is like maybe take that denominator and call that u. And therefore du dx is just going to be 1, which basically means du equals dx. So now if I do my substitution, now that is an integral we can solve. Don't try and use the power rule, because it doesn't work. This is a special case. The integral of 1 over u du is just natural log of u. So now, if I want to convert back to x's, natural log of x plus 1 plus c. But since they've given me this point. They want me to solve for C. So I'll plug in 1 for Y and 0 for X. Now, if you haven't done logs for a while, you may have had to refresh your memory. So we have 1 equals natural log of 1 plus C. Natural log of 1 is 0. So this is 0, so it turns out C equals 1. So the final answer would be natural log . Any questions on that one? I think on the exam, they're nice to you. I mean, what they could do is just give you some integrals to solve, and if you don't have any rules, then you can assume, wow, this must be one where you have to do substitution. Although I think on the test, they may actually, in the instructions, sort of say, solve these integrals using substitution. So they're sort of nice to you and give you a heads up. That's what you have to do. And honestly, in the past, on this test, those are the problems people usually miss the most. So you need to practice these. So we have a few minutes before we give a quiz. So last chance. Anyone want to see 29 or everybody's good with it? All right, well, today's your lucky day. It's nice we have some extra time because actually you're going to have 2 quizzes today. And the reason is because when we covered 4.3, where we did the derivatives of natural exponential functions and natural log functions, we never took a quiz on the next class to give you some practice. So the first quiz is going to be taking derivatives of some natural exponentials and natural log. And then the second quiz will be what we did last class, basic derivatives. So I will go ahead and start passing these out. So when you get done, you have 2 quizzes to turn in, and then your homework. Was anybody here? Does anybody not hear the last class that you need? Also need the.
Yeah.
All right. I'll get that also. again, these are like test problems, so hopefully you can do them, or if not, there's some work to do.